be uploaded on YouTube for those who couldn't make it. And I'm going to share my screen now. And so I want to officially welcome you guys to this live session. And basically, it's like I said, intro to C programming. I will be writing our first program, our first C program at the end of, or somewhere along the line in this session. And it's going to be the famous Hello World program, right? So I hope you guys are excited as I am. So I'm going to share my screen. Okay. Um, I hope you guys can see my screen now. And Miss Sophia. Yeah. Yeah. So I hope you guys can see my screen now. Yeah. All right. So C programming. So what is C program or what's the C programming language? Well, it's a low-level programming language, obviously, and it's a statically typed language, and C can be used to develop a lot of applications, and that includes even can use it to build an OS. I think even the Windows system is actually Windows or yeah, the operating system is actually built using C programming. Yeah. So with C, you can do a lot. You can use to build drivers. I don't mean the car driver. I mean I mean your system drivers. Yeah. You can literally use C in a wide variety of applications, cuts across a lot of applications. Um, and C is also a language where a lot of other languages you know, have literally come out from, and even some languages are literally built on top of C, like the Python interpreter, which is called C Python. The Python interpreter is basically written on top of C, and that's just to make sure that it runs as fast, not obviously as fast as C, but help it to run fast too. It definitely won't be as fast as C because Python is an interpreted language. That's the whole essence of the C Python, which is to interpret the Python code into bytecode first before converting into machine language. But for C, C is a compiled language, meaning that the source code that you write is compiled into machine language, and then it detects all the errors. If there are errors detected, and then you have to like fix the error before it's eventually converted into machine language. But C is a very fast language, very, very fast, and that's because it's closer to machine language. Um, so this is going to be a very short session, so it's not going to like run for too long, and I hope that you guys will understand most of the things that we covered. Yeah. So like I just explained, C is a very fast language, and it is also a good language. Understanding C gives you a very good place to start or to migrate or transition into other programming languages. And yeah, we'll just get to the nitty gritty of things. Um, so basically, how do you write? Well, before then, let me see. We'll be covering just maybe uh, three sections only in this part, and that is let's see. Okay, so we'll be learning how to create C programs, and then like I mentioned earlier too, we will write our first C program, which is the Hello World, and then we'll understand obviously how to organize a C program. Yeah, the organization, the structure of a C program. Um, so basically, there are four basic ways, four basic ways of creating a C program. Let me see if I can write that down somewhere here. Okay, yeah. So this was the packages or the libraries extensions basically that I have to install for Studio Code. So I'm using a Visual Studio Code here. So you can literally run your C program on a Visual Studio Code, or you can use full-on IDEs like C Lion. I think I'm gonna write in the C Lion too. You can use C Lion, or you can compile from your terminal. So I already created a folder here that I'm gonna use. So this is C Lion, and then this is Visual Studio Code. But for Visual Studio Code, you have to install these packages, or these three packages maybe. So I'll just open that. So Sophia, I hope you're watching. So you can type on the extension page here, the extension page. You can just search C/C++. So you should see this by Microsoft, and then you can look at the extension pack also. C++ extension pack. Try and install that too on your from your extension. Let's see. Okay. Okay, welcome guys. So basically, C is a compile language, meaning that it needs to have a compiler. You need to compile it, right? So for the full IDEs like C Lion or Visual Studio, not Visual Studio Code, yeah, Visual Studio. So there's Visual Studio and there's Visual Studio Code, which is your VS Code, yeah. And then I just mentioned C Lion, and then yeah, there are a couple of other ones anyways. C Lion you can use on both Mac and Windows. Visual Studio Code, Visual Studio, I think there's Visual Studio for Mac, but I really do not fancy it because it's not as powerful. Visual Studio for Mac, it's not as powerful as Visual Studio for Windows. Yeah, so that's why I really would not recommend it. So there's already Visual Studio for Mac, but I'm not a fan. I'm not a fan at all. But for Windows, yeah, Visual Studio is great, really great. For writing C programs or C++ or C# programs. And then you can use also Visual Studio Code, but with Visual Studio Code, you have to install most of the things that you need, on the extension page, to be able to, build and run your programs. So yeah, I was mentioning just now. Let me see. I hope you guys can see the screen. Okay, I just increased the. Let's see. Okay, so like I mentioned, there are four basic ways of creating or writing a C program, and I'll mention those. I'll write out those. The first one is the part where you're creating or editing the program, the source code. Yeah. And then the number two is the part where you compiling. Yeah. And then the number three is the linking. I'll explain all of this process. And then the number four is the execution. So it's important to understand. These four basic ways of creating a C program. So the first part is creating or editing, which is basically you writing your source code, writing the program, writing the instructions that you want your program to run. For instance, like we said, the hello world. So you want to like print out hello world. You want the hello world to be displayed on your screen, and then so that source code is compiled and eventually linked, and then it produces. So when it's compiled, this source code, when it comes to the compilation phase, it is compiled and it produces something called, oh my god, my laptop is not charging. 1 minute, guys. Hold on. Okay, that's good now. Someone's mic on. Let's see, who's that? His mic is on. Let's see. Okay, it's all up. Okay, so I was saying, so yeah, when you compile the source code, it produces something that's called the object code or object file. Now, when the object file is created, that object file is now linked. Now, when it's done running or when it's done linking, it produces on Windows. It produces an executable file which ends in like .exe. But for every other system like Linux and Unix system, it produces an executable file, where you can literally execute, with your dot and forward slash. I'll be showing you a practical usage of how to. Is there someone on there? Okay. Well, she make I carry my bike. It's just shaky. Just no, I mean, where? Okay, we'll talk in private later. We'll talk in private later about that. That's funny. Look, I'm gonna be posting this thing on YouTube. Yeah. Well, it's all good, anyways. We'll talk in private. We'll talk in private about that. Um, so basically, the four stages or the four basic ways of creating a C program: creating or editing the source code, uh, compiling, linking, and execution. So this is where you write your source code. I'm just going to put here. This is where you write your source code. Yeah, and then when your source code is written, the process goes from here to okay. So when the source code is written, yeah, the next stage is to compile. So it's like from number one, it goes to number two. But this is after the source code is written. Now, from number one, it goes to number two. When the source code is written, the next stage is to compile. Who's there? Okay. Oh. Wow, people are really tripping in here. Okay. So again, you write your source code, yeah, and then that source code is compiled. Now, like I said, different compile of different IDEs, which is IDE stands for Integrated Development Environment. I'll just put it called Integrated Development Environment. Yeah, so different IDEs come with their own different editors. They come with their own compilers. Yeah. So those compilers will compile. Oh my. Okay. So those compilers will compile your code. Yeah. And then it will create something called object code or object file. Yeah. It is this object file that is now linked. Now, when it goes through the process of linking, it creates an executable file, which on Windows you have the exe, and then on Unix or Linux operating system, you just have an executable file. Probably won't even have an extension, but we'll look at that. And then, of course, this is where you now eventually run the executable. The execution is the part where you run the code, the program that is generated from this linking. So we'll see how that is run, obviously. So this part, which is the creating, is where you write or you develop your program, which is also called your source code. Yeah. So you develop your program in your favorite editor. Your favorite editor for Unix and Linux people, you can literally just do that from here. So I have my terminal, so I can literally let me increase this a bit. So I can go vim lol.c. Now this is another important part. Your C program must end in .c extension, and that's to show that it's a C program. So once there again. So yeah, your C program must always end in the .c extension. This is very, very important. Very, very, very important, guys. It must end in .c. .c. This extension is very important. Without that, then there's no way that the compiler is going to know that this is a C source code. So it must end in a .c. So for Linux and Unix programmers or people who are developing on Linux or Unix, you can use Vim, which is obviously we already know how to use Vim. So you can write your C language. I'm gonna explain this later, but I'll just quickly show you how a C program is done. Then int main void, and then I want to do print f. Then close that. Then return 0. Then close that. Okay, so now for Linux and Unix users, you can literally run it with your Clang or GCC compiler. So it's literally just GCC-C, which is to compile, and then the name of the file. And so when I run this, okay, so you see that it's telling me error. Obviously there's an error. So this is another way of, like I said, I mentioned earlier before I started the video, like, look, guys, errors are part of your life as a programmer. Errors will definitely happen, but do not disregard them, because usually in the error it will tell you where the problem is. And as you can see, it's putting this caret key here to tell me, look, it's telling me that there's a problem somewhere around here. And when I look at it, I realize it's a problem because I wanted to spell void here, and I spelled void, not void. So I'm going to go back to my code and just quickly fix that. No, that's not what I meant. Okay, vim, hello, let's see. So I think some other file must have been created. Okay, let me remove that. Okay, so I'll go back to my vim hello world.c. Yeah, so I'm meant to come here. So now if I try to compile it, remember I said there are 4 stages of writing a C program. The first part I said is, where's my Visual Studio Code? The first part I said is the creating. Now I have just created the source code, and now I am going to compile. So this compilation will generate an object code. Yeah, it will generate an object code that will be that it will generate an object code that eventually will now be linked. Yeah. Now, when this is linked, it will come down and generate executable file. It is this executable file that will eventually be executed on the last phase. So you just try to understand this. These are the basic 4 stages of creating a C programming, a C program, basically a C application or a C program, as you can call it. Creating or editing, compiling. Now, what has happened here? I created the source code, and then when I try to compile, it generated this error, and then it meant that I have to go back and edit, which is why I put this creating and editing, because you can create, and then when you try to compile, at this point, you can have error. It will mean that you have to go back all the way and start all over, which is, at this point, you have already created. It means you have to edit the source code to make sure that the error passes. Now, when it compiles, it creates an object code, an object file. For Mac, I know that it ends in .o, like that, which stands for the object file. For Windows, though, I am not sure. I think for Windows, I think it ends in, usually creates a file that ends in .obj, .object. But this is for Mac, Unix, or Linux system. Yeah, so it ends in .o. For Windows, I believe for Windows it ends in .obj. I think someone's trying to get in. Okay. So for Windows, when it compiles into an object code, which for Unix or Linux system, it is .o extension. For Windows, I believe it is .object. Sorry guys, I don't use Windows, so bear with me. Now, this object file is now linked. In the linking process, I will explain what that means. In the linking process, it creates this executable file. For Windows, you see .exe. For Unix or Linux OS, it's just, we'll see the file. I think it doesn't come with any extension. And then it is that code that is generated here that eventually executes. And that's the life cycle of a C program. So that is the life cycle of a C program, like you said. So I just did the first part, which is to create the source code. And then I compiled it, and it generated an error. And then I went back to edit the source code. And now I am going to compile it again. So on the Unix or Linux OS, you can use the GCC and then the -C, which is for the compilation, and then the name of the program, and then I'll do. So once that is done, if I do ls now, you can see this is the compilation stage. It has gone through the compilation. That means it did not throw any error. So the compilation phase is completed. Now we'll go to the linking part. Yeah, it has finished up with the compilation. Now we'll go to the linking part. Yeah, so the linking part is where it generates this executable, or for Unix, a different part. But basically, you can also do the same thing. I will remove that hello world again. I remove the hello world again. Let me see. Yeah, hello world.o. So I still have just this. Now, when I go on my hello world on my Visual Studio Code, which is another text editor that you can use. So for people who are using text editors like Visual Studio Code, you can see here on the terminal, you see run build task. So you do the run build task, yeah, and then that will run. It would ask you which of the compilers you're using. For me, on Unix, or for people who are on the Linux, you're mostly using either of the Clang or the GCC. Now, for people who are Windows users, I already asked you to install any of this, which is the C or C++ extension. You'll see it like this, or you'll see the C or C++ extension pack. Yeah, well, it's best to just install both of them. This is for the IntelliSense, debugging and everything, and this is for the extension pack. I think with that, you should be good. Let me see for the CMake though. Um, let's see for the CMake. Yeah, I don't think you need that. So, but anyways, just make sure you have these two on there. And then now to run your program, you open the program and then you build. So first thing is you build the tags, which is like it does the compilation for you. You can see it's asking for which compiler that I want to use. So I'm going to use the GCC compiler, and then it runs the compilation. And then you can see it has generated, for this, it has done all the compilation and the linking. And eventually it has given me the final, the source code to eventually execute, which is here. I put here, creating this compiled, and it linked it, and then it has finally given me the file, the final file that I'm going to execute. So if I come here and I do ls and I see this, so this will be the final file that I'm going to execute. So now I can do hello world here and run it, and then it'll give me the hello world. So you can see that now I have gone through all of this process already, creating, compiling and linking. The VS Code did the compilation and linking, and then I only just had to go through from here, just go all the way to execution. But that is for those people who are using a text editor like VS Code, or if you're using an IDE like CLion, which you can also use. Let me open. I'll close. I'll delete most of those things there, and let's see. Documents. Let's see where. Think playgrounds. Yeah, playgrounds. And then C playgrounds. Yeah, basics. And then LMO. Okay, so I'm going to open that. Okay, so this is for another ID. This is a full-on ID that comes with its own compiler, and this is the CLion ID. So I'll remove all of this also. Let me see. So I remove the hello world, and then I'll remove the hello world DSM thing. Okay, so I have only my hello world.c file again. Now here, once this is done, which I've already written the code anyways. I already written the code. CMake project is not loaded. Let me see. CMake. No, it's not. So I just leave it at this, and then come to build or run. Let's see. I think I'm supposed to build that project first. Oh no, it's not. Hold on. see. Okay, so let me delete this. rn Okay, that's gone. Then I will do new C source file. All right. Then this will be .c. So I'll call this hello. Yeah, I just call that hello. Now this is created, and then I can do my typical preprocessor standard IO.page. Now this is called an header file. I'll still explain this code all over again. I'm just showing you guys how to run this on a C Lion and then printf. And then I want to do, oh my bad, hello world. Then return. Oh. Okay, so I can come here and I think come here and then I'll just go to build. You know what? Really not even getting the hang of this C Lion thing. Thought I could use this. But yeah, you can use this somewhere. I'm not sure yet how to run this. I think you have to, it's supposed to build this first. But you know what? Maybe you can just see how to use the C Lion. I'm not getting the hang of it myself. But yeah, usually I would normally just use the VS Code, or I will do the compiling and everything on my terminal. But this is just to show you that you can also use C Lion, which is for C. This ID is for C. Or you could also use VS Code, or you can use Visual Studio. Now I don't have Visual Studio Code, Visual Studio rather. So I can't really tell you how to go about it, but just understand the processes that it takes. First is the creating, which is the part where you write the source code, and the source code ends in .c extension. It ends in .c extension. Now, when the source code is written, it has to go through the compilation phase, which is the next phase. When it is compiled, it generates a .o file, which is on a Unix or Linux OS, and on Windows, it generates .obj file. Yeah. Now, after the compilation phase, it goes straight to the linking phase. It's at this linking phase, this file goes to the linking phase. At this linking phase, this is where it generates the executable file on Windows or on Unix Linux OS. Then this is the file here that is generated on the linking phase. That's the file that finally gets executed. Now, this is to say that if you are able to go through from 1 up to this point without any errors, then this execution should go successfully. Now, if there are any errors, then it will take you have to go back to all this way again. Now, I'll show you, I'll just show you a quick example of what I meant. So I'll do GCC. This time I'm not going to use the C because I just want everything to, so I want the process to compile and link at the same time and just provide me with the executable. So I'll do GCC and then LOC, yeah. So at this point, it has gone through the whole compilation and linking, and then I can run my A out, and then so it gives me the hello world, yeah. But now I realize after this hello world, you see, it's giving me this percentage thing, and I know why. The reason is I should close my arguments. I'll explain what that means. I should close it with with an escape sequence to start on a new line. So in order to do that, now just notice, you see, I am not editing this a.out file. I am only editing this C file. Remember again, I will always refer to this this part that I said: create, compile, link, and execute. Now, if anything, if any errors throws up, or you have to do any updating, which is going back here, updating is where you do all of this, or editing the source code. If any errors happens in any of this process, you have to go back all the way to fix that error, which takes you back to editing. Creating the source code in the first place is the part where you're creating. Now, when you compile, if you do not have error, it goes to linking. If you do not have error, it goes to execution. If you do not have error, it successfully executes. But if there are any errors in any of these stages, you have to go back and edit the file. I'll keep repeating that so it just takes. So now I'm going back here because I want this thing, this percentage thing, not to be there. And that's because I want it to print on a new line after everything. So I want to put this, which is the backward slash and n, meaning that when these programs run, move the cursor to the next line, so a new line. So I'll save this. Now I have just edited it. It means that I have to go back again. After editing, you have to compile the code again and link and then execute. So I'll go again and do GCC hello. But this time, I am still compiling and linking. I am not doing, if I was going to compile, I'll do the -c and then compile. And this will give me the hello dot. Now remember when I said when you compile, it gives you the O file, it gives you the object code. When you compile, it returns the object code. It is this object code that is now eventually linked. On Windows, it gives you this executable file that is executed. Or on Unix or Linux OS, or I don't know for Linux OS, but for Unix, now I see that it gives you this .out extension. It gives you this .out extension. So, but basically, I'm just going to remove that .o1. So hello.o. And I'm just going to compile and link at the same time. So if I do that, then it's automatically compiled and linked into this A. Now if I run, let me clear, if I run this A again now you can see that there's no longer the percentage because of this new line that I added after this code. But I will explain all of the meaning of all these things inside of this hello program. So again, for the benefit of those who are just coming, who are just joining again, I'll go over the same thing I've been repeating. It's 30 minutes already, 31 minutes already. And I've repeated this for, I can't even remember how much time again. But I'll go over it. These are the 4 basic steps of creating a C program. The first part is you create the source code. Once the source code is created, it moves to the compilation stage where you have to compile the code. Remember, C is a compiled language. So it means that you have to compile. The code has to be compiled. Now, when the code is compiled, it returns or it brings out an object code. Yeah. Now, this object code, or for Unix or Linux system, it ends in .o. For Windows, it ends in .obj. Now, this code that is as a result of the compilation is now linked. In this linking phase, it generates an executable file on Windows or executable file on Unix or OS, Linux OS. Now, whatever executable file that is generated is what will now eventually be executed here. If there are still no errors from going from 1 up to this moment, and there are no errors when it's being executed, then your program will give you your desired output. Now, at this point, I will explain each of this phase again. At this point, I've already explained this part, which is the part where you write your source code, the instructions that you want your program to do. At this point, the compiler converts the source code into machine language, which is here. But while it is compiling, it will detect any errors in the compilation process. If there are anything that does not conform to the language itself, if let's say you're speaking English and then when you're speaking English where you're supposed to put a noun, you're putting a pronoun, or your sentence is not well structured, English is still very, very forgiving. People can still understand what you're trying to say. For programming languages, it is not like that. They're very strict, and the same applies to C. The compiler, when it notices that something is not well structured or does not conform to his style of writing, it will throw an error. But if it does, then it will generate an object code, which is in the machine language. So if, okay, I didn't do that part. It will generate an object code, which is machine language. And then from that, you move from the compilation, you move to the linking. Now, let me just quickly show you another way of compiling on Unix or Linux. So I will remove these things that are here again. So I'll remove the A out. Yeah. Now for Linux users, I still have the C program. I can come here and I say CC, which is another compiler, -C, which is to compile. Yeah, and then the name of the program. And then I do this, and I still have my lo.o. Yeah, I still have my lo.o, which is the object code from the compilation. Now, the dash C here stands for compiling. If you remove the dash C, it will do the compilation and the linking. Now, the linking part, this part is very, very interesting. The linking part, what this linking part does is it combines all the modules, yeah, that is generated by the compiler from the source code. All of this. So it goes into all of this. This is called an header file. It ends in .h. It is called an header file because it is always at the top of your program. Now, these files, this part here, the full part here is called, let me see. So this is how you write a comment. This is how you write a comment in C. So this part is called the preprocessor derivative. Yeah, derivative. Yeah. So this is what you call preprocessor derivative, this full part here. Now, what this is saying, in the linking part, it reads all of this. Now, when it's reading it, it sees that, hey, include this header file. Now, so the C program, in the linking phase, it includes all of these things. If this part is not there, if this preprocessor derivative part is not there, let's see what happens. I expect this to throw an error message. So I'll remove that file that's been compiled, lo.o, and then I'll try to compile it again. Let's just say gcc hello. You see that error? Implicitly declaring library function printf. And that's because this printf function is part of this stdio.h. It's part of this header file. Now, stdio.h stands for header file. .h equal header files. Now, this is just an example of one header file. There are others, but in order to, obviously, you want to include them in your program when you're using a function from them. This printf is a function inside this stdio. Now, this is the stdio file. The stdio file. If I search printf, you can see this. Okay, this is print. You can see this printf. It's a function inside of the, so we're calling that function from the stdio header file. This header file. This is part of this. So if this thing is not properly included in this program at the linking phase, then the program will throw an error, which is what is happening here. So you're calling a printf file, but it is not seeing where this printf function, but it is not seeing where this printf is coming from. This printf is coming from the standard IO, and it's even telling you include the header file, the standard IO. So that is very, very important. This is called the preprocessor derivative. This is the part where in the linking phase, it reads all of this and combines them with all of your code. Very important. I'll repeat again. The creating phase, which is the part where you first write the code. And then the compilation phase, where it combines your code into machine language. Now, if there are any errors, you have to go back and edit the source code. You have to go back and edit all of the source code if there are any errors during the compilation phase. If the compilation phase passes, then it goes into the linking phase, which now it generates all of the code from this. It reads all of the code from the preprocessor derivative, all of the header files and everything. And then it literally just, mash everything. It mashes everything all together to generate this part, to generate the executable file, which is then now executed. So I hope you guys understand that part. That is very, very important. Understanding these four basic fundamentals, or these four basic stages or phases of creating a C program is very, very key. Very, very, very key. So I don't know if you write it somewhere, creating or editing the source code, compilation, linking, and then the final stage is the execution. Okay, so at this point, I am going to go into the code properly. Yeah. Let's see. So right now, I already have a sample. Like I said, we'll be writing the Hello World program. So I will remove all of this again and I will start all over. Let me close this, exit. Yeah, sorry about the C line thing. I've never used it before, anyways. I thought I'll be able to share how to use it. I guess I have to
Yes,
see.
sir.
Okay,
Sorry,
so
Mr.
someone
Inke,
has a
sir.
question. Who's that?
Yeah, it's me, Kerde.
Oh, okay. Go ahead, please.
Yeah, I actually not set up this stuff before, so I was trying to follow up as we're doing.
Okay.
I was able to I was able to compile,
Uh huh.
and but when I compiled, I was having my file in probably like a binary format or something. I don't
Yeah,
know.
yeah, that's the machine language. Like I said, when it compiles at this phase, when it compiles into machine code. That's what it,
Okay.
yeah. So if you're on the Unix system, it gives you this .o extension file.
Oh yes, yes, I have that.
Yeah. So when that is done, then you link to generate the exe. For Windows, you get the exe. For Unix, which is for Mac, you have the out. For me, I have the out. So if I do GCC and then hello, this one does all the compilation and linking together. So it gives me the out file. So I have the out file.
Okay.
Yeah.
So am I
So
supposed to check the a dot out file, the out file?
I
Is
didn't
that
get
what
that.
I'm supposed to?
No, no,
The out
it's
file.
okay. So the reason why I'm getting the out file is because I did the compilation and the linking together. So if I remove the A out and I have only my hello.c, at this point, um, it's just the source code. So I want to compile. Now, if I do just compilation, yeah, which is GCC dash C to compile, this one will give me the machine code, which is the O file.
Okay.
Yeah. Now at this point, I think you just have to run also GCC uh, hello.o. Yeah, you see. So you still have to like sort of like run it on the compiler again. But this is called the linking part now. So it now links the machine language into it's sort of like remember what I said about the linking. The linking takes everything and then mashes everything together. The preprocessor derivative rather. Where's the thing? The preprocessor derivative. Where's my other program? Oh, I deleted everything. Yeah. So the preprocessor derivative here, the header files, it compiles it with this source code, yeah, and then it generates the executable file that you need to generate, that you need to execute. So you see, from here first, I did a compilation, and then I got this object code, which is the machine language. Yeah. Now, from that, I ran it through the compiler again, and then that is now linked to the executable file. Now, I can now run this executable file. I can execute that file now. That is where you have to execute here, and then it'll give you the output. Do you understand? Do you get it?
Yeah, I'm trying it out.
Okay.
So,
Yeah, give it a quick try. Let's see.
Sorry, I want to contribute something.
Okay, sure.
yeah, I think it's working now.
Oh, so it's working now, yeah?
Okay.
Yeah, it is.
Okay.
Yeah, I think a faster way is GCC hello.c then hyphen zero hyphen o. Then you can after that hyphen, then you can rename it with any file you like.
Yeah,
For
yeah,
example, the
yeah.
way I do it
Obviously,
now.
yeah. I get that. Except I didn't explain that part. So that is basically if you want it to come out in a particular file name, you want to give it your own specific file name. So which is gcc dash o the lo.c and then you give it like your. So let's say you want it to be lo.o. Yeah, this way it comes out as lo. Oh my god, I need to remove those.
Yeah,
Remove everything.
hello.c before the o flag.
Yeah, yeah, and then the A and out. Yeah. So you run this again.
Because actually doing
Oh
the
right.
compiling first and the linking first, it was confusing me. So I think one of the materials they said I just saw one. You can do it together, man. I think I'll go with that one.
Oh. Oh,
Like
okay. So you want to go
doing
with
the it
the
was
what?
I said I just do it straight up like that, both the compilation, then the renaming to the file I want.
Yeah. Uh oh. Sorry, guys. Uh, I can't remember how to do with the specific file, but
GCC
you, uh huh,
hello.c,
uh
no,
huh,
hello dot hyphen o.
uh huh, and then
Then
the
you can
name.
just put, let's say, hello. Yes.
Oof, man, that's a whole lot of machine code coming up on my screen. Well, you know what? Just compile it like this. Let it give you whatever. Uh, I think you can actually do this. No LL, no such file. Okay, so that would be GCC, the C, then the LO, and then the LO, the C program. No, this doesn't work. No such file as.
I think the hello.c has to come.
Yeah, and then
The
dash
one
O, and the
that
LO. Oh.
C there. I think it's just
Ah.
GCC hello.c. I don't know because I use Linux, so I
Okay,
don't know.
well,
Maybe it's
if you're sure about it, then of course I'll be glad to know how that works. But I've seen somewhere also where you can literally specify a file name. But for me, I just compile. You know, either I can do the compilation of the C file itself, or just run the compilation and linking all together, and then oh my bad, yeah. So just do the compilation itself. Why am I having this? Let me see. What? Am I doing something? Oh, yeah, I believe so. Am I? Uh-oh. I guess I messed up my own code. So I'll just rewrite everything again. CLS, yeah. I'll just rewrite everything again. So I'll include the standard IO again, the age, and then int main, then void, and then printf. So hello and then return 0. Okay. Yeah, so it should be good now. Yeah, so now we're good. Then we can now execute the file that comes out. Exactly. Yeah, okay, so for now, for simplicity's sake,
Hello,
yeah,
hello, Mr. Inka.
yeah,
Please, let me for cutting you, please.
no, it's fine.
I would like to understand some, stuff here, please.
Okay,
One, what you have been saying so far,
yeah,
I could deduce just the following. One, you have already said we should take to cognizance four steps.
yeah, there are
One,
four steps to it, right?
creating, compiling, what do you call
Linking,
it?
linking,
Linking and executing.
right.
So that's what I've understood so far.
Okay, yeah,
Now,
yeah, and
as a
that's the
lay
idea. That's what I
as
want
a
you to
as
understand
a
first. The code,
as a
I have
layman,
not explained the code. I will explain the code, which is the part where I'm getting
let me
into.
please. I'm getting at something, please.
Okay.
Sorry. As a layman,
Uh huh.
you know, if I want to start what do you call it, C programming,
Uh huh.
so what will I follow? What are the steps? Am I downloading some app, or as a particular app I have to do what? I have to first
Did you join us from the beginning?
download. Yeah, 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 yeah.
Well, I mentioned the things that you need to have. You need to have because C is a compile language, so you need a compiler. Now, and I mentioned that most IDEs come with their compiler, and I gave examples of IDs like that. Yeah, which is why I wrote this. So I gave for Sea Lion, which is one. I gave for Visual Studio for Windows users. You can also use Visual Studio Code. I think I explained all of this. I explained all of this earlier.
No, no, okay. It's like I've not joined them.
Or maybe you didn't
I've
join
not
them.
joined them.
Yeah, because I explained all
Yeah.
of this. So in order to run your C program, you need a compiler. It is the compiler that compiles your source code. At this point, it compiles the source code that you've written. It compiles it into something called an object code or object file. Yeah.
Okay, that's to say I have
Yeah.
to,
So this is the part where
go.
you have missed from this IDE part,
Okay,
the compiler
Visual
part.
Studio.
Yeah,
I'll just
for Windows, yeah, this one works on Windows. Yeah.
Visual Studio.
Yeah, but obviously I'm not using Visual Studio, so I cannot show you or tell you how it works. But I'm sure most of the IDs will have a part where you have to build and then run. So I will do it also again on your Visual Studio Code. I can probably say download the Visual Studio Code, then you'll be able to follow along. Yeah, for the Visual Studio Code, let me remove the files again that I have here. So let me see what files I remove the A, the L. Yeah. Okay, so that is gone. Oh, I'll probably just remove everything. So everything should be out now. Well, except for this eating files. So I will just let me just remove everything here. So this is for Visual Studio Code. So you can use Visual Studio Code. If you're listening, you can use Visual Studio Code. But in order to use Visual Studio Code, yeah, you need to install some extensions from the extension pack, which is here. This is the extension pack on Visual Studio Code rather. So you go here and then you type the C /C++. So you see this Microsoft one, this one here by Microsoft. You should see it's about 39 million downloads already. When you have downloaded this, you will see another one, which is C /C# extension pack. You need to download those two, the two. Are you listening? So once you have done that,
How with you?
yeah, these two, yeah, the C/C++ and this. So this one provides the so extension as language support. So you see it has the language support for C and C++. So because C is a compile language, so you need a compiler. So you can see for Windows you need the MSVC, I don't know, Microsoft's whatever that thing means, and then the GCC compiler, which is what I've been using for Mac OS, but it's also applicable. It's also available for Windows, and I think that comes. So yeah, that comes with this extension installed. That comes with this extension installed. This C/C++. So you install this new extension on Visual Studio Code, and you install this also, the C++ extension pack. This is about, as of when I downloaded it, or I don't know, as of now, I guess, it's about 12 million downloads. So you install both, yeah, install both on your Visual Studio, and then you can proceed. Now, when you're creating your C files, your C program must end in .c. So I will create a C file called hello. Again, I'm literally starting all over, but literally I am sure that you now understand these processes. So I'm going through all of these processes, but this time I'm paying a lot more attention on the program itself.
One more thing. One more thing.
Okay.
One more thing. So after the downloading now,
Uh-huh.
well, okay. The next stage is Hello World.
No, this is just a sample application. This is just a sample C program that I want to build. Just to explain,
Okay.
yeah, just to
Okay.
explain the workings. And of course
Okay.
to demonstrate these four processes. These four,
Okay.
yeah, do you understand?
Okay.
Yeah, so this
Okay.
is not like a
They are
major program.
just examples.
Yeah, it's just an example to demonstrate these four processes. It's not,
Okay.
yeah, it's
Hello
not
dot
like a
C,
full
hello
program.
dot O. They are
Well,
examples.
it could be anything. You can name it anything, but it has to
Okay.
end in .c. That is to show that it's a C
Okay.
program.
But you put one hello dot O. It doesn't
Yeah.
end with
So
C.
I will explain all that again. It looks like you didn't get that
Okay.
part because the O I was
Okay.
explaining it here. The O is as a result of the compilation. After it is compiled, you will get this O. But I'll write a sample application again, and then I'll show you what's going on. So in this part, I will not use the LO program again. I want to create a different program that would output my name or do something else. So I will say I'll probably come here and say uh, so touch and then say hello or let me just say goodbye. Yeah, say goodbye dot C. Now you can see here. Yeah, I I literally named this file say goodbye, but it ends in .c extension. That's to tell the compiler that this is a C program. To tell the machine that this is a C program, and so
Okay.
this is the C program that I want to compile. Are you following?
Okay.
So, like I said,
I'm
the
following.
name can be anything, so long as it
Okay.
ends in .c. That's what makes it
Okay.
qualified as a C program.
Okay.
Okay, so now this is the
Okay.
first part of the four processes. Now I just created, well, not created yet, but I'm in the process of creating my source code. Now in this file is still empty right now. If I look
Yeah.
at it, and then if I look at my folder, there's nothing except this file, right? Now I'll open the the file now, and then I want to write my program, which is a set of instructions for the program. Do you understand? Hello?
I'm with you.
Okay. So now what I want this program to do is I want this program to say goodbye to me. So now in order to write your C program, the first things that should be at the top, or in some most programming, most C programs, you probably see something like this, like some sort of comment, and then you'll probably see, written by whatever. But I mean, these are all comments. These ones, the compiler or the execution phase is this part are mostly ignored. They are not executed. Wherever you see codes that are written like this, starting with this and ending with this, they are called comments. They are mostly ignored. So this one I'll just take out. But this is where the main program starts. This part where you see this hash key or hashtag, and then you see this include. This is where the program starts. And these are called pre-processor derivative. I'll put in a comment here because this comment are ignored. It's called pre-processor derivative. Yeah. And in this preprocessor derivative, you are including header files. They are called header files because they're usually at the top of your programs. So one of the header files that we'll be using, at least for the purpose of this program, is called standard IO. STDIO stands for standard input output. I'll write that again. I'll say that and write it again. So that stands for, so STDIO is standard inputs and outputs, which is standard IO. Yeah. So, and it's called, yeah. So files that end in .h, you can see the extension here. Files that end in .h are called header files. Now they are called header files because they are usually at the top of your program. Yeah. So I am still in the process of the first phase here, which is creating the source code. I am just writing my source code. Still in that number one. My source code is not complete. I'm not done writing it. It has not achieved the purpose that I want. I want it to be able to say goodbye to me. Now, in order to move on after writing your preprocessor statement, yeah, every line that you write in your program is called a statement. Now, in order for you to move on from that, every C program, yeah, must contain a main function like this. Now, a function as the name of the function and this parenthesis, open and close parenthesis like this. Now, because C is a compiled language and it is a static language, it means that, let me just mute your mic. Where are you? Okay. Now, because C is a static language, it means that you have to declare the type. I know we have not gone into data types and stuff like that, but this is how you write. Like I said, I'm just going to write a C program and just explain. Later on, in other meetings, we'll get into data types. But for now, C is a static language, statistically typed language. So it means that you have to declare the data type for every variable, every function, or anything that you write, basically. So this one here, what it means is I want this thing to return an integer. This function here, this is a function. The function starts with a function name, this parenthesis, and this type. What this type means here is it stands for integer. So I want this function to return an integer. And then you write the body. You start the opening and close. This is called the body. Inside here, inside these two things here, inside these two things here, is called the body of the function. Now, in this body of the function, I want to call another function. Remember, I said the purpose of this my program is to say goodbye to me. That means I want it to display on my screen goodbye, Yinka. Now, the function that I use to display on the screen is called printf. Now, if I do this printf, you can see from my own Visual Studio Code, it's giving me this sort of like summary. And it's saying this file is part of the standard IO, the stdio.h file, which is here. It means that if this thing, this preprocessor derivative, or if this header file is not included at the top of this program, then this one will throw an error because this is coming from here, from this header file. This is why this is important. Now it could be any. There are several header files, but depending on what you do, what you want to do, what you want your program to do, that's depending on the functions that you want to use here will determine the header files that you include inside of your program. Now, for me, I want this to display something to my screen, which is do by Inca. So I'll use this function. Now, this function, before I go in there, this main function, right now, we said we want it to return an integer. Inside of here, you can choose to have something called arguments. You can choose to have something called arguments. So I'll just put this here. Yeah. So an argument is basically like a placeholder, something that will be used as a part of the program. It probably won't make sense now. So some things won't make sense now. There's no better way to put it. It would eventually make sense later on, which is maybe when we start treating some other topics like data types, like functions. Some of these things will start making sense. But I'll say them here. You can maybe Google it, and then I'll try to explain as much as I could also. But here, in this main file, we can either leave it like that, or you can put in a void word like that. This void means this function is not taking any argument. So you could either put in a void there or leave it blank. It's up to you. But that's in the case that it is not taking any argument. But here, in the case of printf, printf will take an argument. Yeah, it will take an argument. But in this case, when you're now typing out, the actual word that you want it to print, it is no longer an argument, it becomes a parameter. So these are words that are interchangeably used. In this part, it is called parameter. So you could still say it's an argument. Some people call it an argument still, some people call it parameter. It's up to you. When you're not using the actual word, it is an argument. When you're using the actual word, then it's a parameter. That's how I know it to be. But whatever one that you use, you're still making the same sense anyways. So now in this printf function, I want it to...
Sorry, you
Yeah?
put parameter, not parameter.
Oh, I'm sorry. Yeah, thank you for the observation. Thanks. Yeah, so that's a parameter. Yeah, so in this printf, I want it to, like I said, display something to the screen for me, which is goodbye, Yinka. Now I want to use this escape this escape sequence or escape statement, which is \n, which denotes when this function is run and this is displayed to the screen, I want you to move the cursor to the next line. So this is one line, this is another line, this is another line. So when it prints goodbye Yinka, the cursor will come down to the next line. But my statement will read on the output will read on the first screen. Okay. So once this is done, yeah. Okay, this has to be here. So once this is done, then I want to return 0. Now, what this 0 stands for is like telling the operating system or your computer, like, look, at this point, the program ran successfully. That's what the 0 is standing for. At this point, the program ran successfully. So you can exit now. So that's more like an exit. Like, okay, this program ran successfully. Oh, my bad. Now, for every line of statement that you write, you have to end it with a semicolon. For every line of statements that you write, it has to, this semicolon here marks the end of the statement. Yeah. Now, every function basically must have a return statement. But like I said, every C program must have a main function. Are you understanding it?
Yeah, I'm getting it. Now,
Okay.
I want to clarify this. So it depends on my operating system. So if I'm using Windows now, it will be OBJ, return
Yeah,
OBJ.
exactly. If now this is the source code, now I've just written the source code, which is the first part. We are done with the creating part now. Now at this point, this program will not do anything until we go through the rest of this phase. This is for C language, yeah. Or if it's Python, you can literally just run your Python code. You execute. For Python, you write the source code and then you execute. Yeah, and then it interprets the Python interpreter interprets it, and so that's another process. But for C, after the source code is written, you move to the next phase, which is the compilation phase. Now, if you are not using any of these guys, any of this text editor or integrator or IDs like that, then you have to do your compilation by yourself. Yeah, so your compilation, you can go on your command line. I think it's there or something. So there on your command line, you can do GCC. Yeah. If you want it to compile, now when it is compiled, when you do the compilation, on Windows you have .obj file. On Linux or Unix, we have .o. So I'll do the compilation, which is this. Yeah. And then the name of the file of this C program file, which is say goodbye. Yeah. So when I run this, I will get this say goodbye.o, which is the machine code. So the code that we wrote here in English in human form that we're able to understand has now been compiled into machine language. I'm not going to open this because it's all gibberish. I'll just open it for you to see. You see that? Obviously, no one can read this, but it's not even been interpreted very well by the editor. So this C program here has been compiled into machine code that only the machine would understand. At this point, we have just moved from here to the compilation. Now we want to link it. Now, if the linking is successful, if we had an error, we would have to go back to number 1. And then to fix the error, you have to edit the source code. Now, once that source code is edited, during the error, when you experience the error, you compile again. Now, if the error passes, if the application passes successfully and there are no errors, then it will generate this either OBJ file or .o file, depending on the operating system you're using. Now, when you have that file, you link that file. Now, linking that file will generate you, on Windows, it will generate an executable file called .exe. Yeah, so I will go again and use the GCC. Now, at this point, I want to run this through the linking phase. the name of this, the one, the machine code, the one ending in OBJ or the O for Unix systems. If I run this now, it gives me this out file, which is my executable. For Windows, you will see the exe after the linking phase. Now, the exe that is generated is now the program that will be executed here, which is the last phase. For Mac, I have a.out, which is going to be what will be executed. Yeah, let me remove that a.out again, see if I can rename that. So I want to say goodbye. Let's see. Okay, maybe just say goodbye out. Okay, that's not working. So I'll just take that out. So I'll link it, which I have this a.out. Now this is the file that eventually gets executed. For Unix and Linux, you can just execute like this. For Windows, you know how to execute. You just double click on the exe file, and it will run. So if I do this now, I will have goodbye Inca, which is my intention for the program, which is what I want the program to output for me, as I wrote in there. So I hope you understand. Now, at this point, when it printed this, it returns this to the system, to the operating system, that look, you can now, take control, whatever. This program has been compiled, or all the processes has completed successfully. So I hope that makes a lot of sense. Do you understand that?
Yeah, we're following.
Yeah. So basically, wow, just to explain this simple concept, I've used over 1 hour. Why, I'm glad that you guys at least understand it. I am so glad that you guys understand it. So basically, I believe that I have achieved the point of this session, because I stated in the first part. Let me see where I wrote that. I wrote that somewhere. So I mentioned three things that I wanted to do, which is number one is to explain, how to create C programs. We will be discussing how a C program is organized, and we'll be writing our first C program, which is the hello world. So I believe we have accomplished that goal. So if you guys have any questions, and nice
Are
try
we
to
recording
ask.
this?
What?
Are we recording this
Yeah, yeah,
tutorial?
yeah. This is being recorded,
Okay.
but I think I'm gonna stop the recording now. Now that you know, I
What?
believe that.
Why?
Well, do you have any question? Because I believe I'm done.
I think for today, no question. No.
Yeah, that's why I need to stop the recording, because it's literally done. I have accomplished the goal, the objective for today's session, which is just three: how to write C
Okay.
programs, how to organize your C code, and then writing out our first C program, which have been. So this is our first C program. I wrote the hello world, the first one. Now I'm writing goodbye Inca, and then we have gone through all of these processes, which is creating or editing source code, compiling it, linking, and execution. Now, okay, let me just show you how to do that on the Visual Studio also. So that means I'll remove these two. So I have only the C program. Now on Visual Studio, if you install those extensions that I asked you to, this and this. So on your Visual Studio, you just open the C program, and then you go to your terminal. I don't know if you won't probably. I don't know if you show. Yeah, I think it will show like this on Windows somewhere at the top here. So you go to your terminal, and then you click. First, you want to run build task. This is to compile, but this part will do the compilation. This part it will do this two phase. It will compile and it will link. So if you do the run build task, it will give you these two processes at the same time. It will compile and link. So that means at the end of the day, you're expecting an executable file. So I will run this here. Let me close this. Go to terminal, run build task, and then I'll choose my compiler. I'll use the GCC. So when I do that, you see build finished successfully, and then it generates the executable file here. So now At this point, this is the file that gets run. So I can open another terminal from here. I can open another terminal. I can either click this plus sign to run another terminal, or or did you hear that? Or I can literally just go back to my command line, which is here.
I can't see the screen again. No,
Can you still see this?
I can't see the screen again.
Really? Did I stop my screen? I didn't. It's still sharing.
No, you're still sharing. I can
Yeah,
see it.
yeah. Every other person can still see my screen.
And what happened there?
Well, okay. You know what? At least you saw the part where I did run, where I clicked on the run build task on VS Code, right?
Yeah, this I didn't
Mr.
see.
Aladi, I think it's because you're on video. Stop doing video and it will show.
Okay, I'm on video. Oh, sorry.
Oh, you actually. I didn't see that. Okay, can you see the screen now?
Hey, well, I'm yet to see that, sir. I can only say DGX slash LGNNN slash stats.
Okay, could it be your network?
No, it can't be. You're connected.
If probably the network, I won't be able to see anything.
Yeah, it's not network. You're connected.
And what is happening now?
Well, I
Yeah,
can't.
maybe you should end it then come in
Yeah,
again. Let's see
maybe
how.
you should probably do that. Yeah,
Okay.
you should probably exit and join the session again. But I hope the rest of you guys understand. The whole explanation of how to run the program, how to create a C program, and how to run it. I'll probably look for that command line code where you'll be able to specify a specific output file. I think I tried
Yeah,
that. I tried that once, but I don't know. I just kind of just like the
like
whole
oh,
compilation and linking
I
phase.
don't know. I'm connected with my phone, but my system is here now.
Uh huh.
Eh, so it's GCC hello.c hyphen o,
Mm-hmm.
then any file name that you can name it with,
Yeah, but that doesn't seem
and
to work. Let me see.
and it worked for me. I run the file again just now.
Okay, let me just try that again. Then all right, so GCC and then the name of
Yes,
the C program
hello.c.
and then dot
Yeah.
.o and then let me just say hello. So
No,
just the
no,
name.
yeah.
Oh, okay, that seemed to work. Yeah. All right. Yeah, that works. Yeah. Right. Yeah, that works. That works. Exactly. Well, that's cool. Yeah, I know I tried it once before, but well, yeah, this is cool also. So you can literally compile and link to the specific file that you want. So this is both compilation and linking. So this compiles the C programming and then it links to this file. So this becomes your executable, which is cool. Fortunately, this guy's not here. Oh, he's still here. Okay. Well, like I said, that'll be the end of the session. I need to end it. It's already 1 hour and 18 minutes, so I need to end this so other people can be able to watch and not spend a lot of time with me. So I'll stop the recording now. So for those who have not subscribed to my YouTube channel, please do subscribe, like, and share. Thank you.